Good day. In today's lesson, we will be measuring current and potential difference in a series parallel network. We will also determine the resistance of a resistor. The apparatus that we will be using are three 1.5-volt batteries, connecting wires with crocodile clips, 3 ammeters, 4 voltmeters, and 3 resistors of known resistance. As a precaution, please do not use the AC wall socket for this experiment.
Okay, I have 4 voltmeters here. 1, 2, 3, 4. And I have 3 ammeters. 1, 2, 3. Okay, before we start with connecting these instruments, an ammeter is an instrument with very low resistance, because an ammeter needs to be connected in series with the circuit element. So if we need to measure the current in this 10 ohm resistor, the ammeter must be connected so that there's a single path for the current through the ammeter and then through the 10 ohm resistor. There's no branching. A voltmeter is an instrument with very high resistance, and it is connected in parallel in a circuit. For example, if you want the voltmeter to be connected to measure the voltage across this 10 ohm resistor, then the voltmeter must be connected in parallel. In other words, when the current that flows through the 10 ohm resistor is not the same as the current that flows through the voltmeter. The current would actually branch at this point, and most of the current, in fact almost all the current, will go through the 10 ohm resistor, and a negligible amount will go through the voltmeter so that the measurement can be taken. All right, let's get back to the circuit that we have here. We have 3 batteries that are connected in series with each other, and then the batteries are connected to the 10 ohm resistor, the 15 ohm, and the 22 ohm resistor. You notice this connection is coming from the positive terminal of the battery to this point, and at this point there's a branch happening because there's a path to go this way and there's a path to go that way through this and the 15 ohm resistor, which means at this point the circuit is branching. That means these 2 resistors are in parallel to each other. The branch comes here and ends, and then there's a single path for the current again. And I broke the circuit there. If we connect the circuit there, there's a single path for the current to now go and complete the circuit. And we notice that that is the part of the circuit. I'm going to open the circuit again. By open circuit, what we mean is that the switch is off. At the moment, I don't have a switch here, so I'm opening and closing my circuit with the crocodile clip here. So I'm going to open the circuit, which means no current is going to flow through the external circuit. On closed circuit, when I either put the switch on or I connect the crocodile clip there, the circuit is on, in the on position when it is closed, and current is flowing through the circuit. I'm going to open it again. Okay, now let us look at connecting this ammeter to measure the current in the 10 ohm resistor. What we need to remember is this is the positive terminal of the battery, which means that current is going to flow, conventional current, from positive to negative, right through the circuit and to this point here. So that means if we look at any 2 points in a circuit and look at which is positive and which is negative, we look at the direction of flow of the conventional current. It's flowing this way, which means this point is more positive than this point. So technically speaking, this is positive, this is negative. We need to remember that when we are connecting the ammeter. As I said, we chose the 500 milliamp scale. This is the positive terminal of the ammeter, and where my black wire is connected is the negative terminal of the ammeter. Now, I'm going to disconnect the circuit at this point. I'm going to remove this connecting wire. Okay, that means the circuit is now broken at this point because I'm going to put the ammeter at this point. You see, the ammeter is going to go there. So the positive terminal of the ammeter is connected here to the positive point in the circuit, and the negative to the negative point in the circuit. Now if we look at the path of the current from the battery through this wire to this point where the current would branch, and part of the current will go through the ammeter to the through the 10 ohm resistor. Now let us look at measuring the current going through the 15 ohm resistor. Again, current is flowing in this direction. So this point is positive, this point is negative. I'm going to remove this because now I'm going to put the ammeter here. This is the ammeter, this is the positive point. So the positive terminal of the ammeter goes there, the negative goes there. Now let us look at the flow of the current. Current is going to flow like this. It's going to branch at this point, part of it going that way, part of it coming here, through the ammeter, and then back into the circuit and through the 15 ohm resistor. The ammeter now is part of the circuit. Okay, let us look at the current flowing through the 22 ohm resistor. I have another ammeter here, and this ammeter is going to connect here between this point of the circuit and the battery, which means that, okay, I'm going to remove this wire. This point is more positive than this point. So this point is negative, so the positive terminal of the ammeter goes there. Okay, and the negative goes here, but I'm not going to connect it as yet because I don't want to close the circuit as yet. We will do that once we have connected the voltmeters. Now, this is the voltmeter that I want to use to measure the voltage across the 10 ohm resistor. This is the positive terminal, and this is a positive point compared to this point. This point is negative, this point is positive. So if I take my voltmeter, the positive connection goes there, and the negative connection goes there. You can see at this point, the current is actually going to branch. Part of the current, a very small, negligible amount, will go through the high resistance voltmeter. Most of the current, almost all the current, will go through the 10 ohm resistor. That is supposed to go there. Okay. Because we don't want the connection of the voltmeter to actually affect the current that is flowing through the circuit. Now we want to measure the voltage across the 15 ohm resistor. Again, as we said, that's the more positive point in the circuit. That's the more negative point. So the voltmeter is connected in parallel across the 15 ohm resistor. Now we have our third voltmeter here. Again, the same argument. That's the 22 ohm resistor. This is, if we're looking at these 2 points now, this is more positive, this is more negative. So the voltmeter would be connected just like that. Okay, now the voltmeter is connected there. I want to connect this voltmeter across the battery, okay, so that we can also measure the voltage or the potential difference across the battery. Now, my circuit is not complete because you can see I have not connected this terminal of the, sorry, and the wrong connection there. The positive terminal of the voltmeter there and the negative on this side. We'll connect here, and this from the ammeter will also connect to this point. Now let us do that. No. Let us leave the circuit open but connect the voltmeter across the batteries. Now if we look at the voltmeter, we
see that the reading is 4.6 volts. This is the EMF.
And that is a voltage on open circuit. So this is actually the EMF of the battery. Now when I complete the circuit, that means the battery is providing current to the external circuit. I'm now going to complete it. Current is now flowing. If you look at all the ammeters, you'll notice there'll be readings on the ammeters. On ammeter number 1, my reading is about 92 milliamps. On ammeter number 2, the reading is about 8 milliamps. And on ammeter number 3, the reading is about, sorry, I gave wrong readings. It's on ammeter number 1, the reading is about 92 milliamps. On an ammeter number 2, the reading is about 48 milliamps, more like 50 milliamps, okay? And on ammeter number 3, we're reading on the 100 milliamp scale, so we're looking at around 132 milliamps. The voltmeter readings on voltmeter number 1, which is this one, my voltage is about 0.7 volts. On voltmeter number 2, it should be 0.7 volts again because they are in parallel, and it is. And on voltmeter number 3, we are reading around about 3 volts. Okay, we are reading 3 volts. And on the voltmeter across the batteries, we are reading 4 volts. Let me just disconnect the circuit. It is 0. Okay, it is 0. Okay, so what we've done here is we have looked at how we actually connect the ammeters and the voltmeters. You might find certain small errors in your readings, and that will be due to the error of parallax in the main, because when we read the reading on the ammeters or the voltmeters, make sure that your eye is in line with the graduations so that you don't make the error of parallax. Furthermore, we are reading on the 500 milliamp scale, which means we are reading to quite a high degree of accuracy. So we will find that at times we might be off by a few milliamps in our readings. What we need to check is that the current that is flowing through these two resistors must actually be, if you add the two currents, we should get the current in the 22 ohm resistor, because resistors in parallel are current dividers. Furthermore, this parallel combination is in series with the 22 ohm resistor. That means the voltage across the parallel combination plus the voltage across the 22 ohm resistor should give us the external potential difference across the batteries. So in other words, we should get we should be able to get the the voltage across the external voltage, external potential difference. There may also be internal resistance in the batteries, which means that some voltage is dropped across the internal resistance that is present in the batteries, which means that the voltage across the across the parallel combination plus the voltage across the resistor that's in series with them plus the voltage across the internal resistance should give us the EMF of the batteries. Okay, thank you. Have I done? Let's read the voltmeter readings again, because I think we had the error of parallax there. The voltmeter reading on voltmeter number 2 actually is 0.9 volts, and the voltmeter reading on voltmeter number 3 is 3.5 volts, and the voltmeter reading across the batteries is 4.4 volts. This is actually the voltage across the external circuit. So it's an external potential difference. I'm going to open the circuit now, which is the voltage that is provided to the external circuit. Remember, EMF is equal to the external potential difference plus the lost volts. In other words, EMF is equal to the main current in the circuit multiplied by the total external resistance plus the main current in the circuit multiplied by the internal resistance. What we need to notice here is that the voltage that is dropped across the 10 ohm resistor and the 15 ohm resistor is the same. It's 0.9 volts, not 0.7 volt, what we said initially. That was wrong. 0.9 volts plus the voltage across the 22 ohm resistor, which is 3.5 volts, should give us the voltage, the external potential difference, which is 4.4 volts. Okay. So when you are connecting a circuit, make sure that you know exactly which point in a circuit is more positive and which points are more negative. Remember, when we look at points in a circuit, they are more positive compared to another point. Like this point is more positive compared to that point because current is flowing this way. But if we look at this point compared to this point here is more positive than this point here. Okay, because current is flowing that way. It's not like a point will be positive as a positive point. Okay. All right, now you should get busy to set up your own circuit and take down the readings and vary the resistances as well, vary the positions of the resistors. Maybe you can put 3 in parallel and 2 in series, or 3 in series and the whole combination in parallel with the one, and just try out the readings on the voltmeters and the ammeters and see what you get.
Now set up your own circuit, take your ammeter and voltmeter readings, and then calculate the internal resistance and the resistance of each of the 3 known resistors. Once you have calculated the resistances of each of the resistors, compare these values with the theoretical values that are indicated on the resistors. You may notice slight differences between the experimentally determined resistance values and the theoretical values. If so, why is there this difference? The possible reasons for differences: 1 could be the error of parallax, 2 the instruments were not correctly zeroed, 3 heating of the resistors during the experiment. Remember that every experiment works. If the result is not the one that was expected, then we must account for this deviation. Thank you and good luck.